In this session, we're going to look at the second section in the trig unit 5.2 and looking at right triangles and the relationships of all the sides. All right, so trigonometry is a branch of math that studies the relationships between the side lengths and angles of triangles. Most of the time, we're going to look at right triangles, but in the third unit, we will look at 9 right triangles. The trig ratios can actually also provide a richer understanding of circles. And these ratios you will certainly see again in calculus. And it's also used in many branches of science, including physics, engineering, and astronomy. Okay, so let's take a look at the 6 basic trig functions. The first one here, it's sine. We have sine, cosine, and tangent. This is cosecant, secant, cotangent. And what these are based of is if you have an angle, and the angle can be placed, so here's a right triangle. Let me first say that we're working with right triangles, where here you have a right angle, 90 degrees, and we have one angle. So based on our angle and where, I'm going to pretend like I'm standing here, based on your angle, the sides have different names. So here first, the B, the side that's right next to the angle that I'm standing at, it's called the adjacent side. A, because it's directly opposite from the angle that I'm standing at, it's called the opposite. And C is the longest side of the triangle. This is called the hypotenuse. And the hypotenuse is always the longest side, and it's always across from the right angle. Okay, so sine theta, it's actually just a ratio or a fraction that divides the two sides. Sine theta is opposite over hypotenuse. So it takes the opposite side and divides the hypotenuse. And of course, if our opposite side is A and our hypotenuse is C, we can also express this as A over C. Cosine, we take the adjacent side and divide by the hypotenuse. So just, you're taking two sides and you're just dividing the two, it's a ratio. So adjacent divided by hypotenuse. Again, if we're using A, B, and C as the sides, it's B over C. Tangent is the opposite side divided by the adjacent side. In this case, opposite, we're using A, and adjacent is B. Cosecant is actually the reverse of sine theta, or the reciprocal. So it's actually the hypotenuse over the opposite. And in this case, it's C over A. The secant is the reverse or the reciprocal of the cosine. So it's hypotenuse over adjacent, which is C over B. Oops, that should be C over A. Cotangent is the reciprocal of tangent. So it's adjacent over opposite, and it's B over A. There is an acronym that's commonly used to help you memorize the 6 trig functions. This is known as SO, CA, TOA. And the SO stands for sine is opposite over hypotenuse. The CA is the cosine adjacent over hypotenuse. The TOA is tangent is opposite over adjacent. So if it helps you, it helped me get through pre-calculus when I first learned it. So you can certainly rely on this to help you know the ratios. Okay, so let's take a look at this example together. We want to find the unknown side length using the Pythagorean theorem, and then find the values of the 6 trig functions for angle B. All right, So A, let's just label this given side. So A, here it says it's 8 units long, and C is 17. We don't know B, and we already know we can use the Pythagorean theorem, so let's do that. A squared plus B squared equals C squared. With the right triangle, if you're given two sides, you know two sides and you're missing one, you can always use a Pythagorean theorem. A is 8, so we're going to square that. B is, we have no idea. That's what we're trying to solve in this case. C is 17 squared. 8 squared, 64. B squared, I don't know 17 squared. So let's put that in the calculator. Get 289. Subtract 64 on both sides. B squared is equal to 289 minus 64, which is 225. Of course, we have to take the square root of both sides to get B. And so if we take the square root of 225, we get 15. So now that I know B, I can label this 15. Okay, and then that wasn't the actual question that will help us solve the question. It says, find the values of the 6 trig functions for angle B. So angle B is here. We use big letters, uppercase for angles to represent angles, and we use lowercase to represent sides. And if you notice your angle B, usually the opposite side is little b. Here's angle A, the opposite side is little a, and then C, the opposite side is little c. So here now we're placing ourselves on angle B. So here, this is where we're standing. And so depending on where you're standing, your opposite, your adjacent side changes. So here, if we are at angle B, that's our reference angle. The opposite side is little b. So I'm going to go ahead and label this opposite. The adjacent side is A. And remember, the hypotenuse is always the longest. C is hypotenuse. So make sure that you understand the difference between, like, where is the opposite side depending on where your angle is located. So now that we have that, it says to find all 6 trig functions. That means we have to find the sine, cosine, tangent, cosecant, secant, and cotangent. So let me just kind of write the SOHCAHTOA. It'll help me remember at least the sine, the cosine, the tangent. So sine of angle B is opposite because it's O over H, opposite over hypotenuse. So the opposite side's 15. Hypotenuse 17, done. Cosine of that angle B is adjacent, which is 8 over hypotenuse 17. Tangent of the angle B is opposite, which is 15 over adjacent 8. And all these fractions are ratios are simplified. Now, doing these helps me find the other ones, the cosecant. Instead of trying to remember what was cosecant again, I can just flip this sine over and say it's the reverse or reciprocal of sine, so it's 17 over 15. Secant B is the reverse or the reciprocal of cosine, so flip that over and say it's 17 over 8. So you can see how these are reciprocals of one another. And cotangent, instead of trying to remember what was cotangent again, I know it's the opposite or the reciprocal of tangent. So we're just going to flip that around and write 8 over 15. Okay, so this was done in steps. First, we used the Pythagorean theorem to find the missing side. And then we had to locate, depending on which angle we were at, the opposite side, the adjacent side, the hypotenuse, and then figure out the ratios of the 6 trig functions. Okay, let's take a look at the next example. Here it says use the triangle to evaluate cosecant of 60 degrees. So my angle, I'm going to label it, we are standing right there. Cosecant of, let's go back and say, okay, what's cosecant again? What I usually do instead of memorizing cosecant is hypotenuse over opposite. I usually like to find the sign and then reverse it, but you can certainly do it this way too. So depending on where 60 degrees is, I'm standing there. The opposite side is the root 3. So let's go ahead and label that opposite. 1 is the adjacent side, and 2, the longest side, is the hypotenuse. So cosecant of 60 degrees is your hypotenuse 2 over the opposite side, root 3. Now, if you put that exactly the way you see it, it's right. But then if you put that in my math lab is going to say you're wrong, because my math lab does not like square roots at the bottom of the fraction. So that means we have to rationalize. This is a process where we try to get rid of the roots at the bottom. So how we get rid of roots at the bottom is we multiply the top and the bottom by the root we're trying to get rid of. And when we multiply fractions, you multiply straight across. So this is 2 root 3. Root 3 times root 3 is root 9, which simplifies to 2 root 3. Square root of 9 is 3. Okay, so that's our answer. It's rationalized. Cosecant of 60 degrees is 2 root 3 over 3. Okay, let's take a look at this example here. It says cotangent of pi over 4 is what we're trying to find the two sides there. Here, I don't see that pi over 4. So let me make this bigger because it's a little small. That pi over 4, like where is pi over 4? I don't see it. So I think we first have to convert pi over 4 into degrees to so we know what angle we're talking about. And this from 5.1 to go from radians to degrees, we have to multiply by 180 degrees over pi. So first we're going to convert this to degrees by multiplying by a conversion. And so the pi's are going to cancel each other out. And if you do 180 over 4, we get 45 degrees. Okay, now I know what to look at. So here's 45 degrees. Just pick one. There's 2, but I'm going to pretend I'm standing here. Label the opposite side. Label the adjacent side. Label the hypotenuse. And then go back to, if you're not sure yet, cotangent of pi over 4 is the same thing as cotangent of 45 degrees. And if you're not sure what cotangent is, go back to, you should have this written down, the first chart. Cotangent is adjacent over opposite. So you can write, okay, I need to find the adjacent side. Adjacent side is, okay, let me just write, adjacent side is 1. Opposite side is 1. So this actually turns out to be 1. 1 over 1 is 1. All right, let's take a look at the next identity. So we looked at the 6 trig functions. The reciprocal identities, I kind of also just mentioned it, sine theta. The reciprocal or the reversed, you flip, the flipped version of this is 1 over cosecant theta. Cosine theta is equivalent to 1 over secant theta. Tangent theta is 1 over cotangent theta. They're reciprocal identities because the ratios flip over. Okay, so make sure that you have this written down also in your notes. We also have quotient identities after reciprocal identities. So quotient identities, our tangent can also be expressed as sine theta divided by cosine theta. And cotangent theta can also be expressed as cosine theta over sine theta. Okay, so let's use that, either the reciprocal or the quotient, and determine if we're given sine theta equals 2 over 7 and cosine theta is 3 root 5 over 7. Let's determine all these 4 identities. Okay. So tangent theta, one way, okay, there's a couple ways to do this. One way is to draw a triangle. and the other one is using the identities itself. I'm going to do the identities first, and I'll show you how to do it that way. So tangent theta, we already said. Actually, I think we need more space, so let's just make more spacing. Okay, we already said that tangent theta is the sine theta over cosine theta. So sine theta is 2/7 divided by cosine theta is 3√5/7. And when you have the same denominator, or when you're dividing two fractions, it's the same thing as multiplying the reciprocal. So this becomes 2/7 times 7/3√5. The 7's cancel, and we're left with 2/√5. I think I need more space. I'm actually gonna move this over some more. So 2/√5, and again, we don't want radicals in the denominator, so we can multiply the bottom and top by √5. Oops, that doesn't cancel. And multiply straight across, so then we get 2√5 over these two. √5 times √5 is going to give us square root of 25, which is 3 times 5, and that is 2√5/15. Cotangent theta is cosine divided by sine theta. So we take cosine theta divided by sine theta. Cosine is 3√5/7. We're going to divide that by 2√7. The 7's cancel, and then we end up with 3√5/2. And having a √5 in the numerator is okay, so we don't need to worry about rationalizing. Cosecant theta is 1/sine theta. That was a reciprocal identity. So that what that means is whatever you have for sine theta here, you can flip that around. So here, if I wanted to be form one, right, that's 1/2√7, which is equivalent to 7/2. Secant theta is 1/cosine theta. So what that means, it's 1/3√5/7, which means just flip that around and it's 7/3√5. We don't want radicals in the denominator. So let's rationalize by multiplying the top by √5, the bottom by √5, becomes 7√5 times 3 square root of 25, which is 7√5 times 3 times 5, giving us 7√5/15. Okay, so we've used the reciprocal identities and also the quotient identities to do this. Okay, there's also Pythagorean identities, and this is if you take sine and square it and add cosine squared, it's really nice because this is just 1. So whenever you see sine squared of some angle, so I'll give you an example. If you see like sine squared of pi/6, this could be any angle. And you're taking cosine squared of the same angle, you're going to get 1. 1 plus tangent squared theta is going to be equal to secant squared theta. And 1 plus cotangent squared theta is cosecant squared theta. Usually we use this one the most. Okay, so let's see here. It says given sine theta is 5√5/4. Let's use a Pythagorean identity, sine squared theta plus cosine squared theta to find cosine theta. Okay, so here, because sine squared theta is √5/4. One thing to note, what sine squared theta means this means, I should write it down here. This means it's sine theta squared, which is different from sine theta squared. So when we're squaring the sine, we note that by putting the square next to the sine, because what this one says, sine theta squared, means we're actually squaring the theta, the angle. And so instead of writing like parentheses around sine theta squared, we just write sine squared theta. Okay, so let's replace sine squared theta with root 5 over 4. We have to square that whole thing. Plus, we're trying to find what cosine is equal to, equals 1. Squaring root 5 gives us 5. Squaring 4 is 16. Plus cosine squared theta equals 1. Let's solve by subtracting 5 over 16 from both sides. Just erase this here. So if you're not good with fractions, you could put that right in into your calculator and do 1 minus 5 over 16. And then change that to math fraction. And so we get 11 over 16. And to get rid of the square, take the square root of both sides. So cosine theta is equal to square root of 11 over square root of 16. Square root of 11 is not a perfect square, so let's just leave that at 11. And square root of 16 is 4. So there is cosine of theta. It's square root of 11. All right, so we did 9 together. Let's look at 10. This is the last one that I'm going to share with you with the co-function, well, in terms of the identities, and then we'll look at a couple more examples. Co-function identities is when you take cosine and you have the difference of 90 degrees minus that theta. This ends up being sine of 90 degrees, and this is all degree mode. Same thing of cotangent 90 degrees minus theta. This becomes tangent of theta. Cosecant 90 degrees minus theta here. This is equivalent to secant theta. And that's degree. If you're working with degrees here, if you're working with radians, you have cosine power over 2 minus theta. This is, oops, it's a typo here. That should be theta here. Sine of theta, this is tangent theta. Cosecant power over 2 minus theta is secant theta. So let's do an example. It just makes more sense when you're doing an example here. And I have a typo, so I'm going to fix that. Find the co-function of sine 42 degrees. So what that means is we take the co-function of sine is cosine. So we take cosine, and whatever this angle is, you just take that angle, subtract it from 90. And so that's equivalent to cosine of 90 minus 42 is 48. So you can, like, anytime you have the angle, just subtract it from 90. And then we have to find the co-function of tangent of 2 pi over 5. We'll go for the tangent. The co-function is cotangent right here, or I guess right here, and take the cotangent and subtract them from pi over 2, since we're dealing with pi radians. Pi over 2 minus 2 pi over 5. And so to do this, you can use your calculator again, but instead of putting pi over 2, I'm going to just put the number in the fraction part in. So 1 over 2 minus 2 over 5. And then change it to fraction. And so it becomes 1 over 10. So this is equivalent to cotangent of pi over 10. And what that just means is that they're equivalent. So if you took sine, I'm going to make sure I'm in degree mode. Okay, so I'm in degree mode here. If of 42 degrees, you hit enter, we get 0.669. And if you took cosine of 48 degrees and hit enter, you get the same thing. So that's what it means by co-function identities. If you take 90 degrees, the difference between 90 and that given angle with its co-function, you end up with the same output. Okay, so this is a good leeway. It says use a calculator to find the value of the trig expression to 4 decimal places. The first one being sine of 64 degrees. Because this has a degree symbol, you always want to make sure that you go into mode, and the third line down, look to see that the degree mode is highlighted, and then quit since we're already in degree mode, and just type in sine of 64. And it says to round to 4 decimal places. So we have 0.8988. Cosecant of 67 degrees. You're going to notice here you don't have a cosecant button. The only 3 buttons you have is sine, cosine, and tangent. But we know that cosecant, the reciprocal identity, is 1 over sine. So you have to first know that this is equivalent to 1 over sine of 67 and then put it in. So 1 over sine of 67 is around 1.0864 if we round to 4 decimal places. And cotangent, that's a reciprocal identity. We don't have that on the calculator, so you have to know or remember that that's equivalent to 1 over tangent of pi over 12. And because we're dealing with pi, make sure for this you change it into radian mode. That's very important because if you're in degree mode, it's not going to give you the right answer. So go to mode, and we go to radians and quit out. So we have now 1 over tangent pi over 12. We get 3.7321. So here it's really simple because it's a calculator. Your calculator doesn't work, but you do have to remember to be at the right mode. And also that if you see cosecant, to recognize it's 1 over sine. If it's secant, to put that in as 1 over cosine. And if it's cotangent, to put in as 1 over tangent. Okay, now we're going to move into like what happens if you're given an angle and one side and you want to find one of the missing sides. So here we have a triangle. We know one of the angles, the big A, we know angle A, it's 40 degrees. And we know one of the sides, it's B, 460 centimeters. And we want to find this missing side A. So here, again, place yourself at the angle that's given and think about what 2 sides are we dealing with? Well, we're given B, 460 centimeters, that's adjacent. It's right next to the angle. We're also given the opposite. If you want to, you could label hypotenuse, but we don't really care about the hypotenuse right now. So the trig function that deals with opposite over adjacent, if you think about, so TOA, it's this one, opposite over adjacent. So I know I have to deal with tangent. So knowing that and using this, we have the tangent of the angle. We know the angle, it says it's 40 degrees. Take the opposite, which is A, and then divide that by the adjacent, which is B. But we also know B, so we can just say, oh, B is just simply 460 centimeters. I should just revert this around. So tangent of theta is opposite over hypotenuse. I'm sorry, opposite over adjacent. And now to solve for A, this is a fraction, 460 centimeters. So we are going to get rid of that 460 centimeters by multiplying both sides by 460. So A is equal to 460 times tangent of 40 degrees. And I'm just going to make sure we go back to degree mode. As we're working with degrees, this is super important that you don't forget to do that. So it's in degree mode, and we have 460 times a tangent of 40 degrees. And then it says that A is, I didn't really specify how many places to round to, huh? Let's just round to the nearest whole unit. So 386 centimeters. Okay, let's look at another similar problem. Find the measure of side C. Okay, so the angle that's given is here. Here I'm given the opposite side, and we're dealing with the missing hypotenuse. So the writing SOHCAHTOA again, the trig function that deals with an opposite and then the hypotenuse is the sine. So if we write that again, sine theta is equivalent to opposite over hypotenuse. So we have sine of 39 degrees. Opposite is 24. Hypotenuse is C. We're trying to solve for C. Okay, so to solve for C, we have to get C out of the denominator. And so we get C times sine of 39 degrees is equal to 24. And now to get C isolated, we can divide both sides by sine of 39 degrees. And so C is equivalent to 24 over sine of 39 degrees. 24 divided by sine of 39 degrees. And we're already in degree mode. And says C is equivalent to 38. I really should have specified how we should round. I'm just going to keep it as a whole unit, 38 meters. But just be careful with my math lab, read the fine print, and if it, just make sure you round it to the correct place. Okay. So far we've found missing sides, but you can also find missing angles with just the output given. So here we have sine of theta is equal to 0.3681. It says to round to the nearest degree. That means we have to make sure we're in degree mode, and I think we already are. Yep. When you're given the output and you want to find the angle that gave you that output, what you have to do is use the inverse tangent function. And so what happens is if you do the inverse tangent, you can put the output inside in for the input, so like this, and that will give you the angle. And if you look for the inverse tangent, it's the right here, it's the button right above the sign. You have to do second and then put 0.3681. And that will give you the angle measure. 20 nearest degree means nearest whole number, so 22 degrees. Okay, so if you're given the output like this and we're trying to find the angle, use the inverse sine function. Okay, so here is the last problem. It looks very similar to the homework problem for this week. It says a tower is 103 feet tall that casts a shadow of 112 feet long. Find the angle of elevation of the sun to the nearest degree. Okay, so here, let's see, if we are standing at this angle, the two sides that we're dealing with that are given is the opposite and then the adjacent. And the trig function that deals with opposite over adjacent is the tangent. So we know tangent theta is equal to opposite over adjacent. So if I want to set this up again, tangent theta is equal to 103 plus 112. And we're trying to find the angle. That's the angle that's missing. So we got to use an inverse tangent of 103 over 112. So inverse tangent of 103, over 112 is 42.6, so we're going to round that up to 43 degrees. Okay, so we continue the trig unit from 5.1 to 5.2. I think we covered a lot of identities here. It might be a lot of information. Just make sure you write all the identities down. And again, at any time you have questions, feel free to reach out.